All right, welcome back. We are on Unit 5, Day 2 of logarithms and exponential functions. This is page 5 of your notes. Sorry, I'm going to try not to cough as much today. I'll do my best. If you are comfortable on the warm-up from what we did yesterday, pause this, go to the end of it, and double check to make sure. Just a couple things, though. When you see this, this is, make sure you're kind of reflect over x-axis, which means the y changes to its opposite. And this means the function of the graph, everything, to even the asymptote moves down one. So everything shifts and just gets pushed down one, so it's like a translation. You flipped it and then push it down. All right, so anytime we're doing these, I'm going to ask you for the parent function. So do the parent function first, 1, 3, and then 1/3. And I ask you, when you're doing this, do the x-coordinates change at all? When I'm reflecting over the reflect over the x-axis, the y is changing. I'm also moving it downward, which means it's affecting the y. So no, the x-coordinates do not change. All right, so this means for the parent graph of 3 to the x, to get the negative 3 to the x, so you always want to multiply or divide first and then add and subtract. So I want to change, we can do this several ways. If you want to put it on the graph and put this, and this, and your original graph goes like this. Sorry, I tried. You want to reflect it, which means it's going to flip upside down, so the points are going to go upside down. So this one's going to go here, and then here, and then here. But everything then, sorry, not that one. So then everything is going to be moved down one, so you would go down one. So you take it down one, take it down one, take it down one. So your graph actually goes like this. Your asymptote line, just like the other parts of the equations, get pushed down from 0. So it says, so perform the reflection and then the shift. So now your asymptote is now at y equals -1 because everything got pushed down 1. Now, if you are not as comfortable putting the points on the graph, that's totally fine. What else you can do is you can do all the coordinate work here. So I know you can add, subtract, multiply, and come up with points, but here's maybe some shortcuts. If you are reflecting it over the x, so the y is changing, all the y values change to their opposite. So they go from positive 1/3 to negative 1/3, positive 1, negative 1, 3, negative 3. And then we subtract 1 from each of these. So now we have -1 and 1/3, -2 and -4. So if you are more comfortable having points, figure out what the x's and y's are doing. Multiply and divide first, and then add or subtract after that. Same thing with the x's. So these are your x pairs, and these are your y's. So you'd have -1 and -1 and 1/3. All right, so we are going now to shift a little bit into logarithms. So we're going to study logs a little bit. So a logarithms help to determine a value when the exponent is the variable. Okay, not everything is like x to the 3rd or something. We have these reversed. We have 3 to the x power equals something. And there are times when the x values are going to be decimals or fractions and that sort of stuff. Sorry. All right, so a log is defined as the following. Y equals a sub this. This is the base. This will always remain the base, whether you are in a log form or an exponential form. If and only if we switch around, I'll show you how to switch these from log to exponential in a second. All right, so calculate the following. So anytime we do these, we want to set it equal to some answer. If you want to say x equals y, it doesn't matter. So to go from log form to exponential form, we keep this the same. So we have 2. I drop the log and I switch these two things. So the x comes over here with the 2, so they switch sides. So this is 2 to the x and equals 32. Okay, these are inverses of each other. One is exponential form, like a growth or a decay, and one is log form. So they are just inverses, they are opposites of each other. So if I'm going to do 2 log base 2 of 32 equals x, this is really an exponent. 2 to what power is 32? And you can go through and calculate it. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2 is 32. So how many 2's do we have? Okay, x is equal to 5. Okay, so for each one of these, I'm going to set it equal to the variable. I keep the base the same, 3. I switch these two, so it's x equals 27. Okay, so you figure out 3 to the second is equal to 9, 3 to the third is equal to 27, so x is 3. Alright, next one is equal to x. So I switch the 2 and the x, I leave the 4 alone. 4 is the base with the power of x is equal to 2. Now do not say 4 to the 2, 4 to the 2. That is not going to work because that equals 16. That is the wrong direction. I want to do the square root because that's how I make a 4 become a 2. Remember, as a reminder, the 1/2 power is the root. Square root. Okay, even something like this is equal to x. Base of 10. Power of x equals 1 over 100. Okay, so kind of 2 steps here. We got 2 things going on. I want the 10 to become 100, so that's the power of 2. Now if I wanted to flip it to the bottom part of the fraction, all you do is make it a negative power. So I'm trying to figure out how I make a 10 become a 100, and that's with the power of 2. But now to get it to the bottom part of a fraction, instead of being over, technically over 1, I put to the negative power, so x equals negative 2. Okay, same thing for letter E. 3 to what power is 1? Base is 3, base is here. Anything to a 0 power is automatically 1. When you see stuff like this, 2 to some power is 2, so I said equal to x first. X is 1 because I only want it to stay the same. Same here, if you have 10 to what power is equal to 10? X is 1 again. Alright, stuff we get into now. Your calculators, when you do them, your calculators always function with a log button. This is called base 10. So if you ever see a base 10 in there, so the 10 is down below, that is actually something your calculator can do right away. So if you type in 2 times log of 2.5, automatically the calculator registers this as base 10, so you don't have to do anything else. Sorry, 2.5. So that's 0.8. So something like this. You can type in your calculator, do log negative 2, enter, and it says error, domain error. And this is because if I go back to my original problem, oops, not equals 0, equals x. If this is log base 10 and I set it equal to x and I switch around, 10 to what power is a negative? I can't make an exponent. Sorry, I can't make an exponent. Any of them work with 10 to make it a negative number. So I can make a really, really small decimal, but I cannot make it be a 0 and I cannot make it be a negative number. So This is no solution, does not exist type stuff. All right, so turn over to page 6. So a few shortcuts that you see here. Okay, so if you ever see log to some base is equal to 1, doesn't matter if the a is a 12, 4, 10, whatever. This is automatically equal to 0. So these are shortcuts. If you just need to go through the problem and do them, that's fine too. But these are shortcuts. Anything with base 1 equals 0 because that means a to some power is equal to 1. So anything to a 0 power is equal to 1. So this has to be a 0. We saw a couple of these on the other side. When you have these two are the same, you automatically have 1. Okay, so this is because a to some power is equal to a. Okay, and that's always a 1. Okay, same idea here. If you have a to a, you always get a 1. But this time I have an x here, so it's like these cancel each other out and you're just left with whatever the exponent is here. Alright, and this last one here, log a of x, log a of y, this means the x and the y have to be the same if the two sides are going to be the same. So, a little bit of stuff you did on the other side. Write this in exponential form. So this means keep the base 2 and just switch your sides around. So put it into exponential form. 2 to the 6 equals 64. And these are true statements. 2 to the 6 does equal 64. Now, the only thing we haven't done is reverse it. So this stays the same. So we have to put it into log form. 4 is here, 4 goes here. And then again, we switch those two numbers. 16 is equal to 2. All right, this last couple things here, we're just solving, again, a couple shortcuts here. Log base 2, log base 2, cancel each other out because they're the same, so x is equal to 3. Using some of your shortcuts, when you see these two numbers are the same, it's just 4 to what power is equal to 4, and this is automatically x is equal to 1. Letter C, we're just switching them around, so 4 to the 1/2 power is equal to x. So exponential form, so this is a square root, so this is like root of 4, so x is equal to 2. On this one, x is still my base. I have my base as x. I switched the 3 and the 8. Third power is equal to 8. So start small when you're doing these. If you're not sure, 1 times 1 times 1, so 3 of them equals to 1. Not work. 2 times 2 times 2, so I need 3 of them. That is equal to 8, so x is equal to 2. So I'm just trying numbers, basic numbers, not real awful ones, but just some basic ones. Last one here, base 5 stays the same. 5 1 power is 1 over 125. So first of all, I think 5 to what power? So 5 times 5 is 25 times 5 again. That is my 125. So far, I know 5 to the third is 125. But I want it 1 over 125, so this means my 3 has to be a negative to make it go down to the bottom part of the fraction. X is negative. All right, that's it. Tomorrow, if you want to work ahead, you are more than welcome to. We're going to work through page 7 and page 8 and doing that sort of stuff, and then coming up the next day, so we're going to do a review and then a quiz on Friday. Bye.